Greetings. Today we'll differentiate inverse trig, or inverse sine, cos, and tan. Okay, so let's get cracking. First we want to differentiate this guy, sine inverse x, which just reminding you, looks something like, boom, boom. What does sine look like? Sine goes to something like that. That's inverse sine. Okay, we're down here is 1, -1, pi on 2, and negative pi on 2. Okay, so I have a domain here between 1, -1, and 1. That's the domain of my sine inverse. So, how do I differentiate this guy? Well, I take y equals sine inverse x, and I obviously don't know what to do with that. So I rewrite it as sine. So I could say x equals sine y. Now from this I can't find dy dx, but I can find dx dy, which goes to sine, goes to cos. So we're differentiating with respect to y, cos y. And I can flip this guy, dy dx equals 1 on cos y. Now this is okay, but I've got cos y. I want everything in terms of x. Okay, I've got y equals, I want dy dx. I want it in terms of x. To get it in terms of x, I'm going to come back to this line here and draw a triangle. The sine of angle y is equal to x on 1. Just think about that. The sine of angle y is equal to opposite on hypotenuse. Bit of Pythagoras' theorem will give us that this side here is 1 minus x squared. Cos of y equals square root of 1 minus x squared on 1, because it's the adjacent on hypotenuse. I can then put this cos y in here. Dy dx equals 1 on the square root of 1 minus x squared. Voila. Now, time for cosine. Y equals cos inverse x. It's going to be the same process for all of them, okay guys? So I'll just run through it for you. Cos inverse looks like, just a refresher, you went up like that. Oh, remember we cut his domain off there. That's still 1, that's -1, that's my domain. So exact same procedure. Y equals cos inverse x. X equals cos y. Find dx dy. Dx dy equals cos goes to minus sine of y. Now I have to draw a different triangle here. I'll just flip it. Dy dx equals -1 on sine y. Now you could probably guess what it is, but it's kind of a different triangle, isn't it? Because here I'm saying that the cosine of angle y is x on 1, which is x on 1, which makes this side 1 minus x squared. Sine of that angle y equals 1 minus x squared on 1, and then again I can pop that down there. Dy dx equals -1 on the square root of 1 minus x squared. Done. You can see that they're the same, except one's a negative. Okay, and I'll come back to that in one of the examples later on. Lastly, y equals tan inverse x. What does that look like? We look something like that, where I had my asymptotes, and his domain just kept going, right? So, y equals tan inverse x, x equals tan y, dx dy equals, what did tan go? Tan went to sec squared y, dy dx equals 1 on sec squared y. 1 on sec squared y, 1 on sec is just cos. So dy dx equals cos squared y. Alright. This is a little bit different to the other guys. Tan always is. I don't know what that means. Y opposite OA. What's that? 1 plus x squared. So it's already different. The other guys had minuses. This guy's got a plus. dy dx equals, well, what's cos of y? Cos of y equals adjacent on hypotenuse. Subbing those guys in here, I would get, well, that's 1 on the square root of 1 plus x squared, all squared, or, it's not going to fit on the page, I'll just get rid of that because it squares the square root. Boom. Done. 1, 2, and 3. Right, now I've got these 3 derivatives. I'm just going to open it up for the general, if I have any functions. Okay, what if I've got over here, what if I've got y equals sine inverse, oh geez, I don't know, 3x squared plus 2. Okay, some function in there. So again, you can probably see from the previous videos what will happen. I'll just do it for the first one. Let's say y equals sine inverse f of x. Okay, this is a bit repetitive at this point, but I'm going to put that u in. I say, well, u equals f of x. That means du dx equals f dash x. Also know that if that's u, then y equals sine inverse u. I can say now that dy du equals 1 on square root of 1 minus x squared. Then I come back and I use my nice little trick and I go dy dx equals dy du times du dx, which equals f dash x times, that should be a u up there at this point, sorry guys, u, and I'm going to sub that u back in. Okay, I'll do that now. 1 on square root of 1 minus f of x squared. That's it. Sine inverse goes to, let's pop that on top, f dash x, the derivative on top, 1 minus the function squared on the bottom. Done. Cosine, I'll just come straight down, equals the exact same procedure. Okay, run through it if you want. On 1 minus f of x squared, but it's a minus, tan, oh, there we go, tan goes to f dash x on 1 plus f of x squared. So what would my friend up here go to? Up here, well, this guy's just going to be the derivative, which is, what's that, 6x. So dy dx equals the derivative of that inside function divided by square root of 1 minus 3x squared plus 2 all squared. Now, obviously, that line goes all the way, that line goes all the way. expand that out, simplify, but okay, let's just leave it like that. Alright, so now I've got my three general-ish or for function cases of sine, cos, and tan inverse. I just want to do two examples. Number one is just so, well, we can be exposed to it. This, you're going to see d by dx of sine inverse x on 3. Okay, we're going to come across these where it's x on a. That just tends to happen. So I want to play around with this and see what happens. Using just that one up ahead, well, I know that f of x equals x on 3. So f dash x equals a third. Right, so now I can just use that and I go, well, this derivative here, that equals to f dash x, which is a third, on square root of 1 minus x squared on 9, that function squared. Okay, now this is a bit messy, so we're going to try to tidy it up. That third is going to, well, that 3 is going to fall down. Okay, so I get 1 on the 3 outside of a big square root, and now I'm going to add these fractions. I'm going to get the same denominator there. So that's 9 on 9. So I get 9 minus x squared on 9. Cool? Now, square root of 9 is 3. So that 9th will come out. That'll be a third. That's going to cancel with that. So all I'm left with is 1 on square root of 9 minus x squared. Now that's really quite nice. Okay, if we did it our function way, we've got this, which is a bit yuck. You might see this again. This is another form, and I'll just write, and we go, well, if y equals sine inverse x on a, so I've just got a linear function, okay, well, but it's on the bottom, then dy dx equals 1 on square root of a squared minus x squared. Okay, so this is just another little guy that'll come in handy. Boom, 1, 2, 3, 4. All right, last example is this one. I like it. It's nice. Differentiate that. Pretty straightforward. Okay, hence prove the identity. This is the bit I like. I like this identity because this is an angle and this is an angle. I know that sine and cosine are complementary, so of course they're going to add to pi on 2 or 90 degrees. If I could put in any value I want, okay, but obviously that's not good enough and I have to prove it for every single case. But let's just put in sine inverse. Well, let's choose, what do we got? A half plus cos inverse a half. Sine inverse a half is, what's that? Which angle has a sine of a half? Well, it's that guy, isn't he? He's pi on 6. Cosine inverse a half, who has a cosine of a half? Well, it's that guy. And it's pi on 3. They're complementary. Pi on 2. Boom. Done. Okay, but now let's step it out how they want. Well, it's not done. It's just one particular example. But hopefully you can see it'll work for all of them. Y equals sine inverse x plus cosine inverse x. Dy dx equals 1 on square root of 1 minus x squared plus the derivative of that, which is the same thing but minus. Alright, 1 minus x squared equals 0. Okie dokie. The derivative function equals 0. What does that mean? That means that the derivative, who has a derivative function of 0? The only guy that has a derivative function of 0 is some horizontal line. I don't know which horizontal line it is. Where does that cut? What's the equation of that horizontal line? Well, let's try and find out. Since I know it's a horizontal line, I know it's a constant. Therefore, I could say that sine minus 1x plus cosine minus 1x equals some constant. Which one is it? Is it orange constant or green constant? Well, now all I can do is, what I can do is just chuck in a value. Let's chuck in x is 0. Sine inverse 0 plus cosine inverse 0 equals sine 0, the 0, cosine 0, that's pi on 2, equals c, and we got it. Therefore, sine inverse x plus cosine inverse x always equals to pi on 2. Okay, differentiated inverse trig functions. Bye.